Imagine looking for a name in a phone book by flipping through every single page, one at a time, front to back. That works. But there's a faster way, one you've probably used without ever giving it a name. And it goes further than you'd think. Because the way you search isn't just a matter of taste, it's two completely different recipes for the exact same job. An algorithm is just a precise recipe, a fixed list of steps for turning some input into an answer, whether it's sorting a deck of cards or finding a name. Flip every page is one recipe. Check page 1, then page 2, then page 3 until you land on the right name. It always works, eventually. Jump to the middle is a different recipe for that same job. Open to the middle, see which half your name falls in, throw the other half away, and repeat, landing in far fewer flips. But what's actually happening underneath when we say one recipe is faster than another? We don't count seconds. A fast computer running the slow recipe is still running the slow recipe. Instead, we count the number of steps the recipe takes as the input grows. Flip every page's step count grows exactly as fast as the phone book itself. 1,000 names means up to 1,000 flips. Jump to the middle barely grows at all. That same 1,000 names takes about 10 jumps, and doubling the book only costs one more. That pattern, how the step count grows as the input grows, is what Big O describes. Constant steps that never grow. Logarithmic steps that grow painfully slowly, linear steps that grow in lockstep, and quadratic steps that grow as a square, diverging fast. Push a little further, and those growth curves stop being an abstract idea. They start deciding who wins. Big O isn't an exact step count. It's an upper bound on how fast the steps can grow, usually for the worst case, and it deliberately ignores constant factors, so a worse Big O recipe can still win on a small enough phone book. But once the input is large enough, growth rate is destiny. An O of n log n recipe on an ordinary computer will beat an O of n squared recipe on a much faster one. The recipe matters more than the hardware. So next time you skip straight to the middle instead of flipping every page, remember, you didn't just get lucky, you picked the recipe whose growth curve was built to win.